Black holes.
Hi, I'm Rahim Fahad and you are watching Acidice. What would happen if you fell into a black hole? Imagine you're floating in space. Ahead of you is a perfectly dark sphere surrounded by a glowing ring of superheated gas. It does not shine because no light can escape from it. This is one of the most extreme objects in the universe, a black hole. What exactly is a black hole, and what would happen if you accidentally fell into one? Let's find out. A black hole isn't a giant hole in space. It's actually an object with so much mass packed into such a tiny region that its gravity becomes unbelievably powerful. Most black holes form when massive stars run out of fuel. Without the outward pressure from nuclear fusion, the star collapses under its own gravity. If the remaining core is massive enough, it compresses into a black hole. At the center of every black hole lies something called a singularity, or at least that's what current physics predicts. It's a place where matter is compressed to an incredible density, and our current theories can no longer describe what happens there. Scientists know this is where our understanding of physics reaches its limits. Surrounding the black hole is an invisible boundary called the event horizon. Think of it as the point of no return. Once anything crosses this boundary, not even light can escape. That's why black holes appear completely black. Now, imagine you're in a spacecraft heading towards one. At first, everything just seems normal. If you're far away, the black hole behaves just like any other object with the same mass. You could even orbit it safely, just as Earth orbits the Sun. Despite what movies often show, black holes don't get roam the universe, sucking up everything nearby. You only get into trouble if you come too close. As your spacecraft approaches, something strange begins to happen. The stars behind the black hole appear distorted. Gravity is bending the paths of light itself, creating a spectacular effect called gravitational lensing. The universe seems warped around the black hole, almost as if space itself has become a giant funhouse mirror. Closer still, time begins to behave differently. According to Einstein's theory of general relativity, stronger gravity slows down time. This effect is called gravitational time dilation. To someone watching from a safe distance, your clock would appear to tick more slowly. Your movements would become slower and slower until you seemed almost frozen at the edge of the event horizon. But from your point of view, nothing unusual happens to time. Your watch keeps ticking normally. Your heartbeat stays the same. You continue your journey toward the black hole. You continue your journey toward the black hole, unaware that distant observers see something completely different. Then comes one of the most famous and frightening effects of black holes, spaghettification. Gravity gets stronger the closer you are to the black hole. If your feet are closer than your head, they'll experience a stronger gravitational pull. This difference stretches your body longer and longer while squeezing it thinner and thinner. If the black hole is relatively small, this stretching could become fatal before you even reach the event horizon. But surprisingly, larger black holes are different. Supermassive black holes, like the ones found in the center of most galaxies, for example, the black hole Sagittarius A in the middle of the Milky Way, have event horizons that are much farther from the singularity. The difference in gravity between your head and your feet at the event horizon is much smaller. In theory, you could cross the event horizon without immediately noticing anything unusual. Of course, escaping would still be impossible. Once inside, every possible path through space and time leads inward. It's not simply that the black hole's gravity is pulling you back. The structure of space-time itself has changed so dramatically that moving toward the singularity becomes as unavoidable as moving forward in time. As you continue falling, tidal forces become stronger and stronger. Eventually, no material, not even the atoms in your body, could withstand the enormous gravitational differences. What happens when you finally reach the singularity? The honest answer is nobody knows. General relativity predicts an infinitely dense point, but quantum physics suggests that infinities usually mean our theories are incomplete. Scientists believe a future theory of quantum gravity may explain what really happens inside a black hole. Some ideas suggest information might somehow be preserved. Others propose that black holes could connect to other regions of spacetime through theoretical structures known as wormholes. But so far, there is no experimental evidence that this actually happens. Black holes remain one of the greatest mysteries in modern science. Even more fascinating, black holes aren't completely black. In 1974, physicist Stephen Hawking proposed that black holes slowly emit tiny amounts of radiation due to quantum effects near the event horizon. This process, now called Hawking radiation, means black holes can gradually lose mass over incredibly long periods of time. For stellar black holes, this process is unimaginably slow. They would survive for far longer than the current age of the universe before finally evaporating. So, will you survive falling into a black hole? For a small black hole, almost certainly not. The intense tidal forces would tear you apart before reaching the center. For a supermassive black hole, you might cross the event horizon alive, but once inside, there's no known way to escape. Your final destination would remain one of the biggest unanswered questions in physics. Black holes challenge everything we think of and we know about gravity, time, and the universe itself. They remind us that even after centuries of scientific discoveries, the cosmos still holds mysteries waiting to be solved. And perhaps that's just what makes black holes so fascinating. They aren't just cosmic monsters, they're laboratories, where the laws of nature are pushed to their absolute limits. If you enjoyed this video, please subscribe.